The broadcast is now starting. All attendees are in listen-only mode.
Okay, folks. Just finished up the other webinar. We're going to get started with a lot of people in here. We wanted to give everybody time to hook up. All right. So, again, my name is Mr. Tom Dybick. Been teaching engineering at Charlotte Latin for 30 years. Been involved with the Science House and the Maker community and Fab Foundation. And this is part of Amazing Mechatronics. And we started to learn to use Tinker Circuit to simulate using Arduinos. Last time, people asked multiple times, are we having actual hardware there? No, we're simulating it. Why are we simulating it? So everybody can participate, folks. I love the fact that you all have the hardware. You're either using Raspberry Pis or Arduinos, and you can code this stuff. That's sweet. But we want to get everybody involved. If you find you like this, there are plenty of job opportunities. So, what's an Arduino? Well, there's all kinds of versions for an Arduino, but it's basically a chip that looks like this or this. Here's a chip, over there's a chip, and we use everything from 3D printers to drones. Now, what we're going to do as Arduino hardware, we just show you this so you see you plug it in. And I'm going kind of quick right now. I'm just reviewing what was covered last time, and then we'll go into we'll explore some new things in the second half of this. So there's Arduino. There's a power jack on this particular one. It's where we connect a USB-B is a USB mini. But the important things I want you to get here is just how we get power for our projects. So we can get 5 volts. We get a ground. We can make this just make the Arduino like a battery. This is where we go for analog pins. These are where they collect a range of data. Weather, how gray is it outside? How warm is it? Those are all a ranging temperature. Where digital is on or off. Is the LED on or is the LED off? Right? Are you live or are you? So it's very digital. These other parts are probably more worried about if we were doing the hardware. We're going to skip over it this time. Okay. Now, really important for the competition. Listen up, everybody. For the competition, you have to wire everything to a breadboard. Can't just wire it directly. So, under the hood, you need to understand how a breadboard works. Inside that breadboard, it's plastic on the outside, but it's these metal clips. I always sacrifice a breadboard. I have a couple old breadboards, teachers, and I break them apart so the kids can see actually how it works. And they insert in there. And we talked about how anywhere along this on this red line, all the way up, if you connect here, you're connected here. It's like one long connection. True on the ground, all the way there. On the inside, it's all horizontal. So 16 A, B, C, D, and E, you can see A, B, C, D, E. 16 all connect. 16A and 17A do not. And this shows that as well. These slides will be made available to people when we get done with the class. Oh no, tell me I can't see your screen. Oh no, oh no. Oh, let's go back to it. I apologize. It's awful. Going back to electronics. There's the breadboard. So 16 A, B, C, D. Hopefully you can see your screen. Yeah, everybody's there. All right, sorry, folks. I usually run a second computer. That's why I should always run it so I can look to see. Okay, now you've got it. So we'll just start back up again here real quick. I apologize. Pretty dopey. All right. So we're going to start with electronics here. All right. And what we're seeing is we're going to use a breadboard. Okay. And a breadboard, it uses an LED to get connected. We talk about, just as I mentioned, along these columns on the outside, connect up there, connect all the way down there, they're the same. And then you can also connect them horizontally. All right. So if you connect here, it's the same thing as down here. Here is to here. If I come down to 16 on this, 16A connects to 16E. But if I connected 16A to 17A, they wouldn't be connected electronically. Okay? All right, great. Now, and here's another vision of that same board. And generally, it's important to stay color-coded when you're teaching this and learning this, folks. You can use any color wires and things, but if you use the same ones, it's a lot easier to troubleshoot your mistakes. So generally, red's considered higher potential, higher the voltage side, and the ground is the other side. And then here's horizontally. They're all connected. Notice one D and E are connected, but one E and F are not. So it's just on the left side or right side of that. Now, the reason these are incorrect and correct is, remember, resistor of current always goes down. Everything goes downhill from greater to lesser. So from order to disorder. So if you think about it, remember we said this was connected all the way down here? That blue rail and that red rail is always connected here. Well, if you connect this resistor just on that rail alone, it doesn't do anything. The current has a choice. You can go up to the rail, which has no resistance, practically speaking, or the resistor that does. Well, it's going to go along the rail. So basically, this resistor isn't doing anything. Same thing with the LED. All right? And if you did it horizontal, if you took a resistor from, say, 19A to 19F or D, it would be doing nothing. Neither would the LED. Here's the correct way. So always kind of think of this. If you're in these columns this way, make sure you're crossing columns. Or if you're in the columns this way, the long rails, make sure you're going across those columns. So here's a whole circuit. And in fact, let me just so you can see that a little bit better. I'm going to blow that up. So look, here to here doesn't do anything because it go right under that metal rail. It can just do this. See that metal that's right there? It just connects on any one of those rails. It can just ignore the resistor. Resistors act to, if using the water analogy, voltage is the height of the mountain that the water is coming down. The water itself is current. And if you put rocks, say that was a tube coming down a mountain, so that was giving your voltage and your current. By the way, that calculates out to your power. To slow that down, and it's a weak analogy here, it kind of breaks down a little bit, but resistance is pressure not to let the water just keep flowing down the hill. All right. Here's an LED. Light emitting diode. It's something we use in all these. Long leg is positive, negative is ground. Here's a schematic. Once you start using these all the time, the schematics make sense. Also, just tip, this does not tell you physically how to hook this up. So don't feel like you can put the LED, you could actually put the LED after this. Don't feel like you just need to know that you have these connections. It doesn't, a schematic doesn't tell you where to connect them. All right, and there's a resistor. And its color value, you can also click on it in Tinkercad to see the value. So a simple circuit, you go from high potential, long leg of the LED, low leg back. So those of you, some people, one way to practice is make sure you got it there. All right, let's go over here. So what we're going to do is go into 3D designs. There's Tinkercad, and they have 3D design circuits and lessons. And you're going to create a new circuit. So I want everybody to go ahead and get into Tinkercad. I'm blanking my screen just for a minute, so I enter my password. I find if I don't log in, so let me go ahead. I'm a black mine, just so you don't see my screen right now. You log into Tinkercad. I'm already in. Just want to make sure. Good. Let me go ahead and show you my screen. All right, great. So I create a new design. That's going to be in Tinkercad, which has got some really neat things going on now. Circuits, I am struck so much by how fast these things are changing. Now, 2 days ago, you saw private. You saw the LED and things. If I go to settings, I can give it a name, blink, LED, North Carolina Science Olympiad. I'm putting it all right there. I put LED. I can make it publicly shared. I can say the changes. Also, and then I go to tinker this if I wanted to. I can also copy it. I can move to projects. So I can go in there and say, hey, what project do I want to move this into? So you can organize things there. If I copy it or duplicate it, there it is. I can give it another name. So, but I'd rather you did that right off the bat, if you would. You can duplicate it, but what I'd rather see you do, go into Tinker Circuit, create a new circuit from scratch. We're still practicing this. All right. Over here, we have basic electronics, but there we go with Arduinos. I would just go all, I'm going to go all here, and I'm just going to search Arduino. And teachers, if you want to email me, I'll talk to you about the A-Tiny. You can do many of the things you can do with an Arduino R3, but just have this little tiny chip. There's something you got to add to it, but these chips are just a couple dollars. Now, don't have all the really nice features this Uno has, but it is for experienced teachers, something to consider to save money. All right, so now I hit R. So there it is. I'm moving it to where I want to be. This cord is when I plug it in. If I start the simulation, there it is. All right, and then I got to get my breadboard. Type in breadboard up here. And I'll stop here in a minute to give everybody a chance to catch up. We're going to use a small breadboard. Don't use the mini. It doesn't have the rails in it. I want you to have the rails. So I hit R there. Put it right like this. Okay. And then what? In a real lab, we would always, I'd hit a power to here, hook up an LED, and just make sure I'm physically, it will do things. So I'm going to take a ground. I'm going to take 5 volts. I'm going to go to here, click once, here, click again, click, send in 5 volts. I'm going to go, boom. And since I just talked about the importance of, I don't want to do that. If you click down there, you can change it. I'm trying to get my, not sure why it's not, delete that off again. So let's do it again. So I'm going to go 5 volts. I should be getting a window up that says wire, and I'm not sure why I didn't get that time. Let me try this again. Sometimes my webinar software does it. Not sure why. Let's try this again. Let me try this. Well, isn't that nice? I'm not getting any. I don't. That's telling me my component list. I can export and save it. But right up here is the labeling. Hopefully, I'll get it to come back on here a little bit later. That will allow me to change the color here. So I'm going to go ground here. I'll click again. And folks, if I'm just let me see if I close this up. Maybe that's what's going on. Start simulation. Turn it on. It's not doing anything, so that's fine. Anybody sees what I'm doing wrong, that it's not reason why it's not bringing up. Usually what it'll do is it'll bring up, it'll say you have this wire and you can change the wire like we saw last time. All right, so we've got that. I can then go, I'm going to go back over and look for other things. Maybe if I click and turn that off. No, it's really wild. And it's not, if you're in the simulation, it doesn't do that. But no, for whatever reason, I'm not getting it. Here's a resistor. I'm going to pull this out. Oh, good. So now we have the resistor. That's what I want to see, except for I want to get for those wires. I'll change that in a minute. Let's make it 300. I just happen to know that on LED, 300 is a good level. I don't want it 300,000. I want 300 ohm. So I'm going to take that resistor. I could have done it off the positive or the negative. It doesn't matter. I'm going to hit R. In this case, I'm going to come off the negative right here. Now, see, it came up. So we're going to make this black. We're going to make this red. Clicking once. Wasn't doing it before? No, it is. Good. It's really important to keep that in mind because here's why. We're going to go take a, we'll search an LED. And I'm going to slow down here in a minute, folks. I know I've gone very fast. Take R, but this is kind of a review from last time. All right, so there's my LED. The long leg or the short leg or cathode is there. That's the negative end. Here's anode, the positive end, or the. Then what I'm going to do is click on here, over to here. Not in the same wire. I don't want it to be in this one. I want it to be here and here. Let's change that color. So later on, I'm going, oh, which one am I getting rid of? Now, I'm going to start the simulation. And there's my light. And if I change values of things, if I make that resistance of this 300,000, when I look, the simulation just, it's not bright anymore. You can do the simulation now in real time, which is kind of nice. Now it's bright, and I could always make it very small, and the LED breaks. So let's keep it there, and the LED doesn't. I'm going to wait for everybody to get to this point. Can I give this tip? When you're using a real Arduino or simulating something, you start off with something, make sure it just basically works. Okay, raise your hand once you've done it, because that way I won't start up until we get everybody on here. See how many people here. I got about half who've not gotten to this point. If you don't have Tinkercad up and you're not going to bring it up, raise your hand, because we don't want to wait for you if you have no plans to do it. I really don't think you get much out of this without running Tinkercad, though. To be really honest with you. Get another computer. You can do my computer, go back and forth, but just you want to get in the habit of doing it right along with us. For the testing part, how much do students need to get into detailed circuits like Ohm's law, circuit types, voltage measurements, or is the testing portion limited to troubleshooting Arduino circuit code? It's for troubleshooting. You're going to be asked questions. I'm not going to ask you, calculate Kirchhoff's law and do circuit analysis, right? And tell me, what the forward voltage is or something like that. I'm not going to do that. You're going to have to either build things or troubleshoot things. There is a circuit. What's the difference between the LED and an LED RGB? An LED RGB is something you can programmable. You can make it any color. Red, green, blue, you can make it. They also have neopixels, which are different than that, but there you go. Sure thing. There is a circuit one. I thought it was in high school. I don't think they have it in middle school. It might be in middle school too, where they get into, just building electronic circuits. All right. So whenever you build an Arduino like this, yawn there, sorry. Test it like this. We now know the LED works that. But you know what? We could turn this LED on and off by unplugging it, then plugging it, and unplugging it. But that's like flipping a switch. How about let's try making it so it's automated. So if I want it to blink. So first thing I'm going to do, I'm going to get rid of the red. And I'm going to go from pin 8. I'm going to come out here. I'm going to go right into that one there. And because it's not coming off the 5-volt line, I'm going to make this yellow. Or I'm going to make it, let's make it orange is actually color back. So we got orange. So that's telling me it's output going to the positive over. Totally fine. Now if we start the simulation though, well, isn't that a howdy do? We see the little LED light in here is blinking. We know this is on, but our LED isn't doing squat. Time to check the code. So go down, we look at the code. And again, people are asking, you can't use text. You can only use block. Right? So, in this case, here we are. Power to that. So, build an LED to high. Where we're going to change this. Because the built-in LED is 13, by the way, which you could do. So we're going to pull the built-in LED off. Mine is going to pull it over there. And I'm going to set pin, in this case, since I'm on pin 8, I'm going to set that to high. Then I'm set pin 8 to low. Now watch when I start the simulation. Wow, the LED blinks. But, whoa, it just came on, didn't do anything. What did I do wrong? This is the kind of troubleshooting you're going to need to do. You need to make that pin 8. Now let's start the simulation again. All right, we all set? Can you explain one more time what the short red wire besides the LED is doing and resistor, and why does it need to be there? Happy to do it. We're completing a circuit there, Hillary. All right, I'm going to stop this code while everybody else practices that. Do me a favor, folks. See if you make it blink faster or slower while I explain Hillary if you understand why. Let's look at the circuit. You've got to complete. So here's one leg of the LED. It goes to the ground. Literally, in currency, is you've got to go from higher potential to lower potential. Higher potential is the top of the hill in the water analogy, and the water falls down the hill. Well, the higher potential is the voltage. So in this case, we have 5 volts. That's the top of the hill. There's the ground. So one leg of the LED resistors, the short leg of the resistor is going to go to ground. There it is. The other leg is going to go to the 5 volts. The 5 volts are going to come out of this 8 pin right here. So I connect to here. If I didn't have that red wire, I'll delete it off. We run the simulation. Nothing's happening because we haven't connected the current's going to here, running up and down this red rail, but it's not connected to the LED. If I connect here, let's stop the simulation. Doesn't matter, it's green. Start simulation. Now, the reason I pick the colors I pick is to help me. Now, if it helps me think of this in terms of, well, I want to keep, so I remember it's all coming from the same wire, I do that. Did that help? Great question. Did that help? Will attaching the ground wire to pin 8 have the same effect? No, it will not. But you go ahead and try it, Patrick. Because remember, we got to have high potential and low potential. The ground is the low potential. Does the color of the wire effect change effect? Nope. It's just to help us troubleshoot. It will be. It's going to be. Someone just asked in the test. It will always be hands-on, but you will still. It's both. There'll be parts where you make things electronically as described by the rules, and you'll fill out answer questions. My ground wire is attached to pin 8, and it still works. I'd have to see what you're doing. If they're both attached, I don't understand what you're doing. If you're running your ground to pin 8 and your ground, I'd have to figure. So you're in 2 grounds here. I'm not sure. So send me a screenshot. I'll take a look at it later. How would you integrate a button? Okay, we're going to get to that all in a minute. But right now, we've got an electronic button. It's our code. That's what's turning it on and off. But I think what you're asking is how do we do input and output to this thing? So we're doing output now. Let's do this. Let me challenge you all. Let's get another LED in here that blinks when the other LED, when one LED is on, the other LED is off. Use pins 8 and 9. I will give you this encouragement. You're going to need pins 8 and 9. So it's 8:32 now. I'll give you 3 minutes to at least try getting that situated. Okay. I think somebody is trolling me a little bit because I'm getting the same question again. Are we using blocks or text? And as I have said, it feels like half a dozen times now in the last 2 days, we are using blocks. How do you recommend coloring? Is it just writing them? No, good question. Someone asked about coloring. I recommend that you make the ground always black, your 5-volt or 3-volt red, your outputs orange, your inputs yellow. But once you get into lots of inputs or lots of outputs, use whatever color. The one I really think you should be on is the ground should be black and 5 volts or 3 volts red. That's my way of telling myself it's always on. When I place resistors between E and A, I got an error message saying my LED head was burst. However, when I placed my resistor between B and negative, I got an error. So I did not get an error message. When I placed my resistor between E and A, because you got into my guess is you did something what we talked about not doing. My guess is the current could go through this rail and not hit the resistor. Watch what I do here. Let me say if I did this. Let me stop this. I'll show you how this breaks. Great question. All right, I'm going to take this. I'm putting this on the end. I put my resistor right here. I don't know how you did that, to be honest with you. But my point's going to be, if you do something here where it can only, like, let's say if you had it hooked up like this, and you had your resistor, let me see if this does it. Now, first of all, you shouldn't do that all jammed in there, but let's try it. Let's see if it does it. Yep, that's why you're getting an error message. This current is going underneath this. It doesn't have to go through the resistor. Okay? Remember when we did this thing I showed you about doing it incorrect? If you connect here, the current can go right from here to here. It doesn't have to go through the resistor. And that's what's causing the error you're talking about. So let me see if I can undo all what I just did. And this is why you don't ever share the same hole. Okay? All right, now, well, what you're doing is just the opposite then, Patrick. If I'm assuming you were always keeping your power, I was always assuming you had a ground, so I thought you had two grounds. When you set the code on this to low, it's basically acting like a ground in that situation. All right? You have 5 volts from the power now coming over, and then the ground that goes down. All right. How many people have added the second LED and get them so they blink opposite of each other? Raise your hand. I'm going to put everybody's hands down for a moment. Raise your hands if you've done that. So I get a sense of if I can move on or if I get everybody more time. If you, like I said before, if you're not even doing this with us, you're just watching it and you're not running it on your computer, raise your hand now too, because I'm waiting on you to do it for something you're never planning to do. Okay, more than half have not done this. Folks, it's in your interest to go ahead and do this. You're not going to get as much out of the class just watching a video. I've had a whole career writing computer-based training and presentations and all this, and trust me, you need to have the software out. You'll get a lot more. But I will now show everyone if you didn't know what to do next. So next thing I would do, if it was me, I'd go back over here. I'm going to add a component here. First of all, I'm going to turn off the code so I can get to my things. I'm going to add another LED. All right, I'm going to put it down here somewhere. I'm going to make, just for giggles, I'm going to make it blue. I don't have to do that. I hit R. Any color you want. You could have kept it red. Now, so far so good. And I need a resistor. Well, I can get the same resistor there. So it's a 300 ohm resistor. So I type in, let's see if I can find a resistor right off the bat. Because I got LED, it doesn't show up. There's resistor. I'm going to make the same size as the other one. I'm going to make 300. Okay, so it's sharing the same ground. Those two resistors are sharing the same ground. Now, if I just put a wire here, and we start the simulation, watch what happens. They both turn on at the same time. But that's not what we want. We want them to alternate. The reason they're turning on at the same time is ground is here. That's great. They can share a ground. Generally, you share grounds. Not always. But usually we share the grounds. And then the powers come separately. In this case, the power is still coming from pin 8 over to here. Helps that. Goes over to here. and goes to that one. So yeah, you can get them both running, but it doesn't work. All right, now what happens if we made them separate? So we make this one yellow and this one green, so we can control them independently. Or maybe we keep this one orange. I'll go back to orange just to keep things simple. All right, well, to do that, maybe what I need to do is move this out. I'm going to go over here and delete this one off. And I'm going to delete this one off just so we can get this. I'm going to connect, click here. Let me see how I want to do this. I don't want to cross over each other. Hang on. But I think I'm going to end up crossing over each other. So this one, let's delete this. So we'll start with this one first. We'll click here. Click here. Trying not to cross over here. We'll go into 8. All right. And we'll make that one green. That's fine. And we'll go this one. Go here. We try not to cross over just because it makes it easier to read. We'll make that orange. All right. So now they have separate power supplies. What's the problem here, though? What will happen? Who can predict? Not problem. Tell me, folks, if I ran the code, what would happen? All right. How much faster could it be? Yeah, okay, you can go much faster with slowing you down. The LED could even go fast. It can be blinking thousandths of a millisecond, so it's in thousands normally. So that's the answer. If it's either slow or fast, depends on your internet here sometimes. All right, what, folks, tell me, which one of these, were you still using the old code? Would the blue light come on or red light? If you think the red light would come on, raise your hand. If you think the red light would come on, raise your hand. All right, I'm going to put everybody's hands down. If you think, stop, don't put your hand up. Stop putting your hand up, folks. If you think it will be the blue light that will come on, raise your hand. Well, if you said the blue light, let's take a quick vote. Don't take my word for it. Let's start the simulation. Ah, the blue light comes on, the red light doesn't. And you know why it doesn't? Because we have no code for that. So let me stop right there. Stop the simulation. Let's look at our code. We need to tell it. So set pin 8 to high. We need to set another pin. We set pin 8 to high. We need to set pin 9. That's pin 9. We're going to set it to low. Now, I want everybody to take a moment here and figure out what bit of code do we need to have right here. Give everybody a few moments to think, what would we need to do? Because if you run the simulation now, watch what will happen. Well, same darn thing, nothing. I want that red light to come on, but when that red light comes on, I want the blue light to be off. All right, let me look down here if anybody's got questions on that. Good. People knew really well the blue blink. So here's what we do. We take another pin. We go to here. All right. We make pin 9 high. And this low and high refers to, if you hook this up to an oscilloscope, the low pin high, low pin low, low high are signals on a oscilloscope. But just think of it as on and off, honestly, for practical purposes on here. So now here we go again. There we go. All right. Now, I'm going to stop the simulation. And what I'm going to suggest we do next is, let's take 5 minutes or so. I want you to think about a stoplight. I want you to wire a stoplight, a red light, a green light, a yellow light. So say we're designing the code to do this. We need to think about it. If you have a red light, the green and yellow have to equal the red light in terms of time. So everything stays in cadence. So if I'm sitting at the light, and the light's on for 4 seconds, green could be going for 3 seconds, and 1 would be for yellow for that 1 second to tell you to slow down, and it's about to switch to red. If we made it 3 seconds, 2 seconds, then there'd be a point where both lights would be on, and that would be catastrophic. So go in here, think of red 4 seconds, yellow 1 second, green 3 seconds, and go ahead and make that. Make your light. And also, by the way, over here, you can be naming things. So this, to me, I'm going to name this right now as 2 blinking LEDs. All right? And then, in a moment, you can make a copy of this. Well, that would trash. Go back here to Tinkercad. What I would do is keep saving what I have. So there's 2 blinking LEDs. Now I'll make a copy of this, duplicate it. We're going to call this 3. We're going to call it stoplight. So that way, I don't want to lose my old code. So that way, if I mess it totally up, all my work, I don't lose it. So there's stoplight. So this is the one I would do it. So I'm going to give it a couple more minutes while you do that. I'm going to look at some of my code here. All right, great. They've finally done this. They're finally adding variables in this, so you can do it. Nice. And then if I wanted to do that, they're not quite there, but they're getting there. All right, finally, new changes. Good. I just kind of told him. All right, while you're doing that, I'm going to start doing it. So I'm going to approach this and say, okay, I'm going to change the color of this to yellow because we're already there. Then I'm going to go hide my code. I'm pulling another LED out because there's no sense in so that was red. This is yellow. This is green. So I'm going to hit R. Make sure I'm in the circuits. And since I'm doing that, I'm going to change this color to yellow just because it'll help me remember what I'm doing here. That's yellow. And we're going to make this one green. I'm going to come up pin 7. So that's that. Move that here. Let's make this. Make that green. All right. Now I'm going to look at my code. Set pin. Let's start with pin 9. Drag that over there. So I'm just showing you out loud what I would be doing. I will make pin is 9. I'm going to set that to high. And then I'm going to set pin the other 2 pins to low. So 8, 7. Those are the pins down here. And I'm going to go low. I'm going to hit low. So we said that needs to be 4 seconds long. So I always believe too is you start out, get it running. So at least, hey, this is working. It's taking like, seems like 4 seconds, and then these are turning off. And then actually we turn pin high up, so it's actually a little bit longer. So I'm going to stop simulation. I can do this. Duplicate. Okay, so I'm back to pin 9 again. In this case, I want that one off. I want pin 8 to be high. I want pin 7, which is green, to be low. I want the yellow one, the only one to be on, and this time I only want it to be a second. So now I run this program. I want to see, I would expect this to be on for a second, then the red to come back on. Let's see what happens. Yellow, back to red. All right, great. Did as predicted. Then we're going down for the last little bit. See if I can get this whole area here. It's kind of weird. All right. So sometimes it's just easier, I think, just drop that in like that. Again, I want to keep doing the same way. Take the time to do that. You'll avoid confusion. This is going to be 3 seconds long. All right, so pin 9 is still low. Pin 8, now low. Pin 7 is high. Let's see if it works. Oh no, the green doesn't work. Why is that? Folks, why doesn't the green work? It didn't work for me. Oh, too bad, Colin. Why isn't it working? Why do we have all the colors? The code should work. I don't understand. What is it missing? This is the kind of thing that's going to be on the test, folks. Got to tell me what's going on there. Oh, some are saying no resistor. Well, there is no resistor, that's true, but it's not connected to ground. Now, it might blow up if it wasn't connected to the resistor. So let's stop it. Stop the simulation. So let's just see what would happen. If I took a wire here, that's resistor, and I ran it from here. All right, so let's try that. Red, yellow, green. It's already giving you that warning. So yeah, it would blow up. Or at least tell you, hey, that's a problem. So let's do this. Let's put that resistor that's down there. I'm surprised I can't copy that, but that's okay. We'll go over. We'll hide the code. Pull the resistor over. We're going to rotate it. We're going to make it 300 ohms, just like the others. Now we'll drag it there, and we'll put it right where the green is. Now the green LED's got a ground. It's got high, but it's got to have a ground. Because remember, if it doesn't have ground, there's no difference in potential. It's as if the water is, you've milled a mountain where your voltage is, and then the ground is another mountain that's just as tall. Well, the water just sits there. It doesn't flow down the hill, does it? So let's try this. Red, green, yellow, green. Red, yellow, green. All right, excellent. Stop the simulation. Next lesson, we're going to do inputs. We're doing the LED outputs. Then we're going to start doing inputs. All right, any questions? Raise your hand if you're able to get the, put everybody's hands out first. Raise your hand if you're able to make the stoplight. All right, good. Most everybody did. So I hope you saw out of this how it's a combination of electronics, it's a combination of programming, or it could be both, why something doesn't work. I think the color code here will really help you on deciding things. All right? All right. Any other questions? Let me look over here. How would you read resistors color bands? They go from thousands to hundreds. Don't worry about that. I would just click on the resistor in this program, and it will show you what the value is. I don't like color bands. If I was doing this in real life, we'd use multimeters. Color bands, a lot of the cheap resistors, color bands are hard for me to see. I probably have a little bit of problems with some colors. There will be I forget what percentage of males have a little bit of color challenges. But I just use a multimeter most of the time. And on here, I just click on it, it tells me. Can you show me the code, please? Happy to do it. There it is, folks. Let me bring some more questions. There's the code. I'll leave that up. Now, I'm going to leave it up for everybody that still wants to see it and still want to make this work while we're waiting. The rest of you are more than happy to go. We will post, I will have it posted tomorrow, and you can rewatch it. Share it with your friends. Use it in the classroom. I'm totally fine with all that. All right? Thank you very much. So I'm going to leave it up. So I'll stay on for a little bit longer so people get a chance. I'll also look at questions. They come up. You are very welcome. I'm glad it's helping. Thank you again. Great class. I'm glad you're enjoying it. Where can I find the video? James, everybody that comes to the webinar, I will link. It's on Young Engineers of Today. There's 2 Young Engineers of Today video. When we set it up, I don't know, we had a problem with Google originally setting it up. Watch for the one that was like 350 member people, and we had a bunch of videos on there, a ton. Look for it there. I will also share a link with you. I share a link to everybody that's in this that come to the webinar. You'll get it probably by tomorrow night. It takes it a little while to compress it and then upload it. But when I do, I'll send it out to everyone. If you also subscribe to the playlist, every time I put one up for the playlist, I wish it. Good. You are welcome. How many student teachers came on tonight? I didn't ask. I'm sorry. Oh, Katie asked. Some of the digital pins have PMW or PWM next to them. What does that mean? I'll show you, Katie. It's called pulse width modulation. It's a way for us to dim an LED. We'll explain later. You bet, Lorenzo. Take care, everybody. Good job. Those pins are capable of called pulse width modulation. Folks, I'm going to get something to drink. I'm coming right back. I'm going to leave my screen up so you can record whatever, write down whatever you need. But just give me a minute for my throat. Okay? Thank you. All right. We still have some folks here. Any questions, guys? I'm going to come back up and look, and then we're going to shut this down in a little bit. Thanks. These are very helpful. Good. I'm so glad to hear it. All right. Okay, folks. I'm going to say goodbye night then, all right? Everybody take care. Have a great evening.